Hi, everybody. This is Mike Human from G2M Research. I'd like to welcome you to our webinar on software-enabled flash, large-scale data center revolution for flash storage. You want to jump to the next slide, Sean? So let me introduce Sean Stead. Sean is with the senior staff at Kioxia, and he'll be doing the presentation. Just as a kind of a side, we're recording this webinar. Everybody who registered for the webinar will get a copy of a PDF of the slide set, as well as a link to the recording. That should go out tomorrow or Friday. Also, we're using Zoom. We're going to have a couple polls in the windows that will show up, which we'd like you to participate in. And finally, if you have any questions or answers, we have a Q&A window open. So if you post those, we'll handle them all at the end. And with that, let me turn it over to Sean. Thank you, Sean.
Okay, great. Thanks, Mike. I just want to say, it's a pleasure to be here again to talk about software-enabled flash. If you haven't heard about it, you're going to be very excited. I think this is an amazing trend that's going to be happening to flash storage. But again, I'm with Kioxia, and this is now a Linux Foundation community project. So we'll go into a lot of details about that with our recent public launch of software-enabled flash. And with that, let me kick it off here with the agenda. Today, we're going to see a few key features of how software-enabled flash technology is pushing the boundaries for flash and how it works with cloud data centers. And we'll also talk a little bit about the Linux Foundation, which you probably heard a little bit, but I'm going to show you a little bit on the inside how the structure and how that works for everybody's benefit. And in the end, we'll show you how to get more information and get involved and stay engaged on this exciting new revolution in flash storage for control in the data center. And again, you already know that software is taking over the stack in the data centers and cloud and enterprise and hyperscale storage. And it's changing the paradigm of fixed function hardware. This is done by making the hardware now software definable for multiple functions. And this can already be seen in many cases, including software-defined networking, CPU accelerators. There's a lot of other on the top level or software-defined storage arrays. And this proven concept of software defining the hardware enables you to do a lot of different things with hardware, and you can modify it for the applications that you need. Now, the one thing we want to see is that flash also needs to be software defined. So flash storage historically has been basically constrained by the hard disk drive legacy protocols. And now as we move forward, flash is now software defined. So we can really unlock the capabilities of flash and really unleash some incredible technology that's within flash that's far beyond the capabilities of legacy HDD protocols. So that's what we're going to go through today. And so flash can now become much more than a simple storage device. Or a fixed hardware device as well. By making a data center flash storage device software defined, we've removed this legacy HD protocol limitation and enabled the data center applications to get flash optimized and to meet the demanding and changing storage requirements in the cloud. And all this without continuously updating hardware or the need to rewrite applications to take advantage of the new flash technology. So we're going to go into some more detail on that. And what this is doing is pushing the boundaries of flash. And again, software-enabled flash is a new way to really push those boundaries. And the technology was developed to unlock and extract every bit of value from flash storage devices. And one of the key points is this is an open source software technology. So again, this is available for multiple vendors. And that's one of the key under the umbrella of the Linux Foundation. This enables us to have a relationship with multiple vendors to create the hardware that goes into this environment. But again, the software-enabled flash software is open source for cloud applications to have more control over the storage functionality, including the legacy overhead problems, and it enables powerful new features. We're going to show you about how software-enabled flash improves flash value. So we're going to start with 4 of the basic top-level concepts with software-enabled flash. This includes tenant isolation, latency control, data placement, and flash migration to the ever-changing new flash geometries and generations. Okay. So again, there's this what we call the noisy neighbor problem, which similar to when you're in a crowded space or apartment building or college dorm or whatever. There's a lot of activity going on, a lot of things happening. Maybe it's not that organized, right? So you've got these flash hardware that's laid out, and there's a lot of demands being placed on it, a lot of stuff moving in and out, but it may not be that organized, or maybe certain demands aren't getting the priority that they need. So this is a challenge, what we call the noisy neighbor problem. So these competing needs are simultaneously placing diverse demands on the flash hardware. And with software-enabled flash, the host can better manage one workload from impacting another workload and deliver predictable quality of service through the software. And this leads to the benefit in the data placement to ensure the data with each tenant or workload doesn't impact the others. And if you've been around flash long enough, there are real challenges. This is a real challenge with storage. Now, software-enabled flash addresses the data placement to ensure data with similar lifestyles and access patterns stay together for the best performance outcomes. The net result is software-enabled flash works to maximize flash memory performance in use and minimizes any wasted writes or write amplification. And another challenge addressed with software-enabled flash is workloads can greatly benefit from different latency profiles, as you can see here, whether it's random latency or controlled latency environments. And so here's the question: which of these situations is better? And the clear answer is a vague, it depends, right? So often that's the answer. And sometimes the cloud-based data center applications need to squeeze out every bit of latency performance. And sometimes the priority is for latency to actually be just predictable. So as we continue to build on this isolation benefit, software-enabled flash is pushing the boundaries to deliver optimal I/O latency to each application, all without needing different hardware. So again, this is part of being software defined. You can adjust as needed depending on the application from the host side. So continuing that benefit, software-enabled flash is a choice for multiple software-controlled queuing modes. So here are 3 examples. They're created on a per application or even per I/O basis as needed. And they vary from a simple priority or even round-robin queuing that you may be familiar with. And also, software-enabled flash introduces a very advanced die-time weighted fair queuing, which can take into account the time each type of I/O operation takes on the flash device. These modes are controllable on a per application or, again, even per I/O operation basis. This gives developers the flexibility of defining their own latency outcome profile and maximizes the responsiveness of the application. You can really dial and tune it into exactly the application that you're working on. So, and additionally, software-enabled flash simplifies flash migration by abstracting the underlying flash technology. With the dynamically changing cloud requirements and applications, the challenge met here is to achieve the optimal results without being tied to a single function HDD legacy hardware. Software-enabled flash can improve your total cost of ownership by deploying the latest flash memory technology, for example, higher density QLC flash, and then also speed time to market for new applications. Because with software-enabled flash, the applications can move as flash technology changes from TLC to QLC and now future flash generations and geometries are most importantly supported without any modifying the existing applications that are running in the data center. So it really helps you get your applications to market as fast as possible as you migrate to the higher density and usually more cost effective or performance or whatever the requirement is that you're moving to in the flash technology. So we've talked about a lot, covered, and we'll go into a little bit more detail, but I thought it'd be a good time to just stop and just take a second, get a little idea of where we're at as an audience. Mike, if you want to jump on the audience survey here.
Absolutely. So I'm going to launch the survey and then Sean will continue talking. Just go ahead and answer the questions as well as you can. This is a select one sort of situation. And the question is, what is the biggest problem in your data center when deploying flash at scale? The choices are noisy neighbors, different quality of service or service level agreement requirements across apps, migrating from one flash media to another, managing data placement across flash devices, other issues not listed here, or none of the above. I will launch this and we'll leave it up for a couple of minutes. You should see it, everybody, on your screen. And with that, I'll turn it back to you, Sean.
Okay, great. Yeah, so everybody take a look at that. And so everybody that's joined today, you'll get the, as Mike said at the beginning, you'll get the presentation as well as the survey results. And there'll be another survey we'll have as we move a little bit forward through the presentation here. So again, this is all for all of our mutual benefits, see what everybody's working on so we can focus in that direction. Thanks everybody for participating in that. All right, there we go. All right, so again, software-enabled flash was developed in response to the need for a broad stroke method to unlock and easily access the full power of flash memory storage. And now we're pushing the boundaries of flash storage to meet the growing needs of cloud and hyperscale data centers. With this new software API, flash can behave in a much more predictable and uniform manner. Again, with data placement, workload isolation, we can control the latency and wide multi-protocol capabilities. The key takeaway to reinforce here is this is a powerful way to move forward in large-scale data centers, and it'll be available through multiple industry vendors. So the software-enabled flash is hardware and software working together with a purpose-built architecture. This new platform is optimized to deliver features needed by hyperscale developers and vendors. And these features include the ability to trade off cost performance with optional embedded DRAM configurations, CPU offload to preserve host CPU for applications, and the flash storage can take on this function. Generational and vendor-specific flash microarchitecture and scaling optimizations are available with software-enabled flash. So again, at the top level is the software-enabled flash API and libraries that are in the Linux Foundation, as well as the hardware, which can be made by any hardware vendor for their own specific hardware design. So again, software-enabled flash deployment starts with the open source API software, and we'll have links for that at the end of this. And then again, vendor-specific hardware. So developers can accelerate their new development with faster application time to market because you'll be able to immediately take advantage of the latest generation of NAND. And you can options for virtualized and containerized applications and deploy the full power and capabilities of flash hardware now and as well as into the future with those applications. So at the heart of the software-enabled flash is the Linux Foundation community project development of open source APIs and libraries to support the implementation of multi-vendor software enabled with flash compatible hardware. So primarily the Linux Foundation, what it does is offers a neutral home for code and collaboration and all of the stuff developers need to build and maintain projects from multiple vendors. as well as a means of an ecosystem for creation and community building and support, helping developers gather the necessary elements, and again, with the wide industry support. So whatever the environment or application is, you've seen the Linux Foundation open source software running behind some of the most critical projects in the world, whether it's security, cloud, automotive, blockchain, various hardware and standards. And again, by the numbers, you can see the Linux Foundation specifically is a huge and still rapidly growing critical part of modern technology development, where everybody can work with the best in class ideas and help each other to support the future development of various hardware in an open platform. So there's no worries about specific technologies or something going away. By working collaboratively as an industry. We have multi-vendor support. So when you get behind something like software-enabled Flash, you'll have not only the Linux Foundation open source, but also, again, multiple vendors and support teams behind you as well. So this software-enabled Flash Linux Foundation community project has their standard governance model to help develop the best practices for open source projects, with a governing board for the top level direction, a technical steering committee, which does most of the actual development activities. Plus there's a lot of other creative project and community outreach programs. So as you can see, there are several areas to get involved with software-enabled Flash. You know, it's not just for guys writing code. There's a lot of very interesting things to help continue the development of this as we move in. Now it's becoming a public project. All right, so now having moved through the software-enabled Flash side of things, we'll move to the survey again. Mike, I'll hand it over to you.
Thanks very much, Sean. So let me share the results of the first one. Survey, you should see them on your screen now. The biggest issue that the audience identified was managing data placement across Flash devices. That's 36% of respondents. Migrating from one Flash media to another is 29% of respondents. Other issues was 21%, and that kind of dropped off. The last two are noisy neighbor, different quality of service or SLA requirements, both at 7%. And with that, let me go ahead and start the second poll. And the second poll is, do you have projects where software-enabled Flash could provide value underway or in planning? And we'll give everybody a couple minutes to go ahead and answer that. It should pop up on your screen now. And with that, I'll turn it back to you, Sean, to do the next part of the webinar.
Okay, great. Yeah, thanks, Mike. Yeah, so basically, again, these survey results will be included in the handout when it gets emailed to you later. So again, you can follow up with that. And again, we're just curious where these, with this basic introduction of software-enabled Flash. And again, a lot of you probably already know a little bit about it. But if you're just learning about software-enabled Flash, we're curious to see how you can get this deployed in your environment. And again, at the end, we'll have some follow-up connections you can take a look at as well if you want to communicate later. All right. So we're going to review the basic idea, again, how software-enabled Flash technology is pushing the boundaries of Flash storage, and it's working to help you meet the growing needs of cloud and hyperscale data center development. So again, software-enabled Flash delivers this incredible isolated tenant environments, tiered levels of service, the improved Flash economics, again, the total cost of ownership, because you can move to the latest generation of Flash without having to update all of your applications. And this gives you that faster time to market to take advantage of each new Flash generation. And it's all in this open source ecosystem for multi-vendor, cooperative, best in class for the future and beyond, where software-enabled Flash technology is being called a force multiplier in the data center economics. Again, this project has been in development for many years from the inventor of Flash, and recently just became a live public Linux Foundation community project. Membership is open where you can join, learn, or just view and contribute to help build this better future for Flash. And one final note is keep your eye out for this SEF logo. You'll be seeing this for the software-enabled Flash community project and in hardware, and again, for multiple vendors. And for more information on the software-enabled Flash technology, check out our Linux Foundation community website. That's got the top level of everything. And again, this is softwareenabledflash.org. And this has documentation tools and links to GitHub site for code examples. You can get more information on how to get involved. And again, thank you everyone for joining today. And Mike, I'll turn it back to you. We'll get the Q&A going. If anybody has any questions there.
Thank you much. So let me also share the results of the second poll. No opinion was by far and away the biggest winner. The second one was people planning a project where Ceph would be or could be of some value. Then there's just one each on the we're deploying it or it could have value, and we don't have any that are. So with that, we have one question, Sean, and that question is, I understand the buzzword software enable everything. This is like giving raw Flash to the host to manage, right? While you show some benefits of doing so, it misses many of the other benefits of having an intelligent device. Why do you think this approach makes sense?
Yeah, I guess one of the things, thanks, Mike. So one of the things to take away here as well is software-enabled Flash is an evolving technology. And again, there have been other specific single function projects for Flash that do single ideas. But again, software-enabled Flash technology is a broad stroke approach where we're trying to take advantage of Flash in as many ways as possible. Again, we're focusing primarily on the benefits for the hyperscale and then large scale cloud environments. But again, its capabilities are pretty wide and broad. So if anybody has ideas that's beyond the scope of the basic concepts that I presented here, we may already be addressing those in softwareenabledflash.org. Take a look at that, or our GitHub site. And again, we're open to expanding the capabilities. So I encourage anybody that has ideas to at least take a look and join in the community project.
And I guess one other observation from my standpoint, Sean, is that, here we're talking specifically about software-enabled Flash for large-scale data center deployments, hyperscale, cloud service providers, things like that, right? So I don't think that you guys are saying that this is something that works for everybody, but for that particular class of users, it has a lot of value.
Yeah, it's going to be interesting to see over the years how it eventually evolves into different platforms. But again, we're taking on the biggest need first, and then we'll see how it evolves from there. But there's just so much more capability to Flash as a technology, as a hardware, as a storage device, as a platform than the legacy HDD protocols have been allowing it to do. And again, even the evolution of Flash, not only just the geometry and the layers, but who knows where the whole Flash storage side of things is going to evolve to. But we want to make sure we enable the maximum performance and control with the easiest deployment for Flash. So again, this is an evolving project that just recently became public. And again, I encourage everybody to join and participate and help us expand.
And I would like to thank everybody for joining us on this webinar today. As we said in the beginning, everybody that's registered will get a PDF of the slides that you saw today. You'll also get a link to the video recording of this webinar. Those should get sent out tomorrow or Friday at the latest, but they'll be sent to everybody who registered. And if you have any questions, I think, Sean, you had some contact info on there, and I'm sure you'd be happy to answer any additional questions.
Sure. Yeah. Again, just go to softwareenabledflash.org and you'll find all the connections to communicate with people involved with the project.
Well, thank you, everybody, for attending and joining our webinar. Thank you, Sean, for a great presentation, and look forward to the next webinar, and everybody have a great day. Thank you.
Thanks, Mike. Thank you, everybody.